So in this video, we're going to go through the analysis of our mass specs that I expect to see in your lab notebook for every mass spectrum that you get, right? You hand me a GC sample and I give you a mass spectrum of your compound, okay? In all of these mass spectrum, they might look a little bit different depending on how I grab the data from the computer. I'll always indicate to you what your molecular ion peak is. So in this particular format here, you see this little triangle that tells you what your molecular ion is. That's a really important piece of information because it corresponds to the molar mass of your compound. All right. In another format, I'll indicate it some other way, but you'll know what your molecular ion is for your compound. So following along here, we first analyzed our IR spectrum, and so we know that our compound is a primary amine. All right. So now we're going to analyze our mass spec, and our end goal here is going to be our molecular formula. Okay. Again, we know from our IR that we have a primary amine. Not often do you look at a mass spec and get like immediate functional group information, but there are a few exceptions. And one of those is an odd number for your molecular ion peak. Every other functional group that you were to analyze would give you an even number for your molecular ion peak, except for amines. All right, and so that in and of itself is a helpful piece of information here. I already knew that from my IR, but it just checks out here. All right, so this is a particularly well-behaved spectrum, and so this is what I'm going to show you first is how to analyze well-behaved spectrum, and I'll show you, explain what that means when we get to a poorly behaved spectrum, okay? But for every mass spec. And this is information that needs to be in your notebook. I don't require you to print this out and have it in your notebook. You can just do the analysis in there, but nonetheless, you're going to do this. So first of all, you're going to tell me what your molecular ion is. In this case, it is 73. Then I want to know the M intensity. My molecular ion intensity here would be 72. The other important piece of information here, and this is going to help us analyze this spectrum, is my M+1 intensity. That is 3. And then we're going to do a number of carbon calculation. All right. So our number of carbon calculation, and you're going to have to show your work. Just show me this formula set up. Is the M+1 intensity divided by the molecular ion's intensity, all divided by 1.1 and then multiplied by 100. So if I fill this in, this is a formula we just got to know. We're going to use it a whole bunch. If I plug in my molecular ion intensity, my M+1 intensity, then my molecular ion intensity, and punch this into the calculator, 3 divided by 72 divided by 1.1 times 100, I get 3.78, and then it's like repeating, all right? So I would say that my number of carbons is probably 4. Given my mass spec, right, 4 carbons, that would weigh 48, and then I have my nitrogen and my hydrogens in there. So 4 carbons is reasonable. If I got a number like 10, and my mass was 73, my molecular ion was 73, that wouldn't make any sense, okay? So these number of carbon calculations don't always work out perfectly. This number is pretty close to 4. If it was between 3 and 4, maybe I'd keep both those in mind, okay? But nonetheless, 4, that pretty much checks out for my mass number that I have here. All right, so I shrunk this down to make a little bit more space because I need to do a few more things here in order to get to my ultimate goal, which is that molecular formula, right? That's our ultimate goal here. This is what we need to propose at the end. So the next thing I need to do is a number of hydrogen calculation. And again, I'm going to show my work. So how do I get to my number of hydrogens? All right, so what do I know about my compound so far is that it contains 4 carbons, right? So I'm going to take 4 times that the mass of carbon. The other thing that I know, though, is the functional group. It's an amine. So I know it also contains a nitrogen, right? So then I'm going to take 4 times the mass number of carbon plus the mass number of hydrogen. This takes me to 62. All right, so my number of hydrogens will then be my mass number, my 73, minus my 62. Remember, each hydrogen just has a mass number of 1, so that takes me to 11. 11 hydrogens. All right, so for every mass spec, this is the information that we need. Our mass number intensity, the M+1 intensity. You're going to take those 2 intensities and do your number of carbon calculation, and then summing everything up, you get your number of hydrogen calculation. Okay, so then what we're going to do is propose our molecular formula. That is C4H11N, based on the IR and now our analyzed mass spectrum. And then the last thing we're going to do to round this off is propose a structure. Let's make sure that we can actually draw something, anything. If you can draw anything, that's fine. That corresponds to this formula here. That as long as it doesn't violate our bonding rules. So the easiest thing would be 4 carbons in a row, 1, 2, 3, 4, plus my nitrogen. Does this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, checks out. Cool. Oops. All right, so this is what we need for our mass spectra. These are going to be posted on Canvas after I've analyzed the data, after I've taken your GC of your compounds. Okay, you're going to analyze your mass spectra as such. You're going to tell me what your molecular ion is, M intensity, M+1 intensity, and then importantly, these 2 calculations here, your number of carbons and your number of hydrogens. At the end, your goal is to propose a chemical formula, and then you're going to draw some structure in there that corresponds to that formula, just to make sure that it was a legit proposition to begin with.